Hi guys, welcome you all to my channel Explore Edu to Teach.
Here we are back with another important concept in digital electronics, that is combinational circuits. So this video will be talking basically about the introduction of combinational circuit and some part of combinational circuit, that is the adders and the subtractors. There will be many more videos coming out in the future, including the multiplexers, the demultiplexers, the encoders, the decoders, the comparators, so on and so forth. So all these combination circuit along with their problems, if any, will be covered in all my videos in the coming lectures. This lecture will be concentrating upon the introduction to combination circuit and about adders and subtractors. So if you're really interested to watch these videos, please subscribe to my YouTube channel if you haven't. Follow me on Instagram. The links are given down in the description box. You will get all the updates of all my videos that are going to go live on my YouTube channel, on my Instagram page. Also, there are going to be many formula sheets, many shortcut techniques, many kind of other updates which are going to go regularly on my Instagram page also. My Instagram page also reads Explore Edu to Teach, so please do check it out and do not forget me to follow over there as well. So, beginning with this particular concept, combinational circuit. So, first of all, before beginning with different kind of combinational circuits, let us understand what do you understand by combinational circuits. So in combinational circuit, the output level at any instant of time are dependent only on the present level of input at that time. So to put it in simple words, my output depends upon my present input. When you talk about sequential circuits in the future, it will be something else. So here you have to remember that whatever I'm giving in my present input will be affecting my output. So the output at any instant of time only and only depends upon the present level of input. That is what is combination circuit. So to define combination circuit, the output at any instant of time will only depend upon my present input. I hope I'm very clear with that. So let's start with the first combination circuit, that is the binary adders, in which we'll be talking about half adder, full adder. So what is basically a half adder? A half adder is an arithmetic circuit that adds two binary digits. So there are two inputs and there are two output. The output will be in terms of sum and carry. So basically half adder is an arithmetic circuit that is used for adding two binary digits. The output is going to be in the form of sum and carry both. So if you look at the block diagram, we have a half adder in which you have two inputs A and B, and we have the output sum and carry. The inputs are A and B. The sum is A XOR B and carry is A into B. So this is sum, which is given as A XOR B, and the carry is given as A into B. If you have to put it in one particular logic diagram only, you can put it as this, in which you have same inputs A and B giving the sum and the carry. As I told you, if we have two inputs, the combinations possible are 0 0 0 1 1 0 1 1. The sum is A XOR B, so that is going to be output. The carry is going to be A into B, so that is going to be output. So to just summarize, adders are basically arithmetic circuits. Half adder is basically an arithmetic circuit that is used for adding two binary digits. So if there are two inputs, there are going to be two outputs for it, which is going to consist of my sum and carry. Since it is a half adder, it's going to have only two inputs. Then there is a block diagram in which we have A and B. The output can be sum and carry both. The sum is basically A XOR B and the carry is A into B. So we have this final logic diagram and we have this truth table. The next thing is the full adder. So the full adder is basically an arithmetic circuit that is basically used for adding three binary digits. So that is the biggest difference. If you know, in case of my half adder, the input had two inputs, whereas in case of my full adder, my inputs has three inputs and two output. The two output indicates the sum and the carry both. So the outputs remain the same, the sum and the carry, but the input, instead of 2 inputs, here you will have 3 inputs. The block diagram will basically have 3 inputs. If you see A, B, C, in case of half adder, we had only 2 inputs, but here we have 3 inputs and we have to output as same, sum and carry. So what are going to be the equations? The sum is going to be A XOR B XOR C, where the carry is going to be A into B plus B into C plus A into C. I have directly given you the equations. I have not gone into the derivation part of it because this is what is important for you to remember. However, if you expect a video on the complete derivation part, do let me know. I'll try to bring it out in the future videos as well. But for you, what is important is to understand the difference between half adder, full adder, their functionality, and the equations. Once you know the equations, drawing the diagram is just a logical part of it. So you have A XOR B XOR C, and you have A into B given here, B into C given here, A into C given here, which is all done with now here there is a mistake. I'm very sorry for this. Here it's a mistake, it's a blunder. I'm very sorry for it. It should be a OR gate over here. It should not be a AND gate. It should be a OR gate. Okay. Please remember this thing. Here there is a mistake. It has to be different. It cannot be a AND gate. It has to be a OR gate. I'm saying this thing. Please, if possible, make a correction of this. So it's A into B plus B into C plus A into C. There will be a OR gate over here, not a AND gate, which will sum all these 3 variables. So I hope I'm very clear. So I'll just give you understanding about this. So the half adders can be half adder, full adder. The half adder gives you 2 input, the full adder gives you 3 input. The output can be in terms of sum and carry. Half adder consists of 2 inputs and the output can be sum and carry. Sum is A XOR B, carry is A into B. Similarly, you have full adder, which is the arithmetic circuit which is used for the addition of 3 inputs that and 2 outputs, sum and carry. The block diagram is A, B, C and the output is sum and carry. The sum is A XOR B XOR C and the carry is A into B plus B into C plus A into C. You can put it logically into diagram. Again, I'm repeating, this is a mistake by me over here. I'm very sorry for it. It should include a OR gate over here. Okay, OR gate, remember that. Now, next point is about a binary subtractor. So again, we have two kind of binary subtractor. You have the half subtractor and the full subtractor. Again, you know, in terms of your half subtractor, you will have 2 inputs. In terms of full subtractor, you will have 3 inputs. So let us read. A half subtractor is again an arithmetic circuit that subtracts one bit from the other. So when bit B is subtracted from bit A, difference and borrow is obtained. So if you know, in case of my adder, I had 2 inputs and 2 outputs, half adder, and the outputs were sum and carry. Here the outputs are going to be difference and borrow. I hope I'm very clear with this. So if A and B are the inputs, the outputs are difference and borrow. Difference is given as A XOR B and the borrow is basically given as A bar B. I hope I am very clear with this. So in case of my half subtractor, you are basically going to subtract B from A and there will be 2 outputs, the difference and the borrow. The 2 inputs will lead to 2 outputs. The output will be difference and borrow as mentioned. This can be the block diagram. The difference is A XOR B and the borrow is A bar B. So you can show this in the form of a logical diagram. The truth table, if you see, consists of 0, 0, 0, 1, 1, 0, 1, 1. The difference is A XOR B, so you have 0, 1, 1, 0. And the borrow is A bar B, so just get these values and you are done. So I hope I'm very clear with this. Fine. Next, you have the full subtractor. So what do you understand by full subtractor? A full subtractor is basically an arithmetic circuit that is going to subtract one bit from the other bit. And you will have obviously 3 inputs. The inputs are going to be basically A, B and a borrow in. Okay, there's going to be a borrow in bit which is going to be there, which was obtained, and there are going to be 2 outputs, that is difference and the borrow. So if you look at the inputs, is A, B and the borrow in. The difference is A XOR B in, and the borrow is given as A bar B in, B in, and A bar B. Just put it in the form of a logical diagram, and that's it. So what is very important is you have to understand what are the kind of arithmetic circuits, that is the, if you see over here, the half adder, full adder, the half subtractor, the full subtractor. The half adder will have 2 inputs, the full adder will have 3 inputs. The output will be in terms of sum and carry. The sum is A XOR B, carry is A into B. Similarly, if you have full adder, you have A XOR B XOR C, and carry is A into B plus B into C plus A into C. So similarly, if you talk about binary subtractor, you have half subtractor and full subtractor. Half subtractor is this thing, which you have A XOR B and A bar B, and the full subtractor is A XOR B in, and the borrow out will be A bar B in plus B in plus A bar B. So just put it in the form of a logical diagram and solve the question. So I believe that just make an effort to understand the meaning of this arithmetic circuits. This operations, you remember this equations. Once you remember these equations, drawing the logical diagrams and getting the truth table is not going to be an issue. Fine. So I've tried my best to explain you these adders and subtractors. If you understood my video, please do like, share, subscribe to my YouTube channel, follow me on Instagram. The links are given down in the description box. Also hit the bell icon of this YouTube video so that you get notified every time a new video goes live. And also share it to as many people as you can so that everyone can get benefited out of it. Thank you so much guys for all your support. Thank you. God bless.